Okay, students. So we will start our experiment 4. Just write the heading determination of total hardness of water by complexometric method or complexometric titration. Determination of total hardness of water by complexometric titration. Okay. So we will make you understand in very simple ways. You know the term hardness. Hardness is actually one parameter of water, and if you add soap in water, if it create bubbles, then that water is soft water. If you add soap in water and it doesn't create any bubbles, that is hard water. So water normally of two types, one is hard water, another one is soft water. Hard water means if you add soap to water and if it create bubbles, then it is soft water. If it doesn't create any bubbles, then it is hard water. মানে জলে যদি তুমি সাবান দাও, যদি বাবলস হয়, ফেনা হয়, that is soft water. And if you add soap in water, if it doesn't produce any bubbles, that is hard water. This is there are some chemical explanation. This is due to the presence of different types of salt in water. It may be carbonate salt, it may be bicarbonate salt, or something else, something like that. Carbonate salt means there may be presence of calcium carbonate, magnesium carbonate, sodium carbonate, iron carbonate. There may be presence of calcium bicarbonate, sodium bicarbonate, magnesium bicarbonate. Okay. So if water contain so many types of carbonate and bicarbonate salt, then that water is hard water. It doesn't create any type of bubbles if you add soap on that. And soft water means amount of that salt is of very trace amount, very low amount. And if you add some amount of soap to that water, it will create some bubbles. That is soft water. Okay. Normally, so hardness, today's experiment, we will calculate that amount of hardness creating particles present in water. How much amount of hardness creating particle present in water. So now hardness is of two types. One is temporary hardness, another one is permanent hardness. Temporary hardness means obviously the water is hard water and it obviously consists of some soluble carbonate or bicarbonate salt. And permanent hardness also hard water. It consists contains some salt of chloride, carbonate, bicarbonate, etc. Now, in this classification, we can say temporary hardness means presence of bicarbonate salt only. If water contain only bicarbonate salts, then the water is temporary hard. And if water contain chloride salts or sulfate salts, then water is permanently hard. Okay, so if water contain carbonate or bicarbonate salts, that is temporary hard water. If water contain chloride and sulfate salts, that is permanent hard water. Now, temporary hard water, actually, if you boil that temporarily hard water which contain carbonate and bicarbonate salts, that hardness can be removed. So, hardness can be removed by only boiling of that water, because if you boil, then it will evolve carbon dioxide from that solution. So automatically hardness is being removed. So if any water contain carbonate salts, bicarbonate salts, you can remove that hardness to a certain extent only by boiling that water. Because if you boil that water, it will release carbon dioxide from that salt. Okay. But if water contain chloride, it may be calcium chloride, it may be magnesium chloride, etc. Or it may be calcium sulfate, magnesium sulfate, then that water is permanently hard. Means you can't remove that hardness only by boiling. But if you want to remove that hardness, we need to follow some different water treatment process. Only by boiling we can't remove permanent hardness. Only we can remove temporary hardness. Okay. So in normal sense, you can say that if water contain carbonate and bicarbonate salts, if water contain carbonate and bicarbonate salts, then water is hard water. Okay. One thing I must say, every water parameter is being analyzed in parts per million unit. Okay. That means you know about gram per liter, milligram per liter. Parts per millions means particles in 10 to the power 6 ml of substance. Okay, parts per million means milligram per liter or gram per 10 to the power 6 ml. That is parts per million. So in case of all water parameter analysis, almost all water parameter analysis can be unitized as ppm unit. Okay, hardness also expressed in ppm unit. Okay, or you can express hardness in milligram per liter, same ppm. So now presence of carbonate and bicarbonate is only the reason for the creation of temporary hardness. Now we will check that how much amount of carbonate and bicarbonate present in hard water. Okay. Before that, we will go through this titration, complex symmetric titration. You heard about acid-base titration. Now complex symmetric titration means there will be formation of some complex compound during the titration process. For this, we will use one special compound. This is very difficult to pronounce. That is disodium EDTA. Full form of EDTA is ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid. And name of the salt is disodium EDTA. Ethylene diamine tetraacetic acid. Full form is disodium EDTA. This is a special type of chemical by which we can detect that hardness creating particle present in water. Okay, here we just go through the structure of this disodium EDTA. This is the structure of disodium EDTA. COOH, CH2, COONA, CH2, COOH. Okay, this is the structure of disodium EDTA. Here it contains 6 binding centers. So this is hexadentate ligand. You can count as hexadentate ligand. That means this complex can 6 binding centers and it is known as hexadentate ligands. Okay, one special type of compound. It actually means particularly this complex can bind the metals from water. Okay, this complex can bind the metals from water. Like let us say this is water, and it contains calcium carbonate. For example, presence of carbonate means water is hard. That means temporarily hard. Now, if this complex can absorb calcium from calcium carbonate, then carbonate is free. So that carbonate may be bonded with non-hardness creating particle and will be precipitated from water or will be in the solution but not creating any hardness. Okay, that means this particular complex is able to trap all metal ions that creating hardness. Normally, according to your curriculum, we will only account for calcium and magnesium, which are creating hardness for water. Okay, it may be calcium carbonate and it may be magnesium carbonate. And also mind it, all types of hardness will be expressed in the unit of calcium carbonate. It may be you are expressing hardness for magnesium chloride. Maybe you are expressing hardness for calcium chloride. Maybe you are expressing hardness for calcium bicarbonate. Maybe you are expressing hardness for magnesium bicarbonate. Whatever it may be, but hardness always being expressed in the unit of calcium carbonate. Because what is the molecular weight of calcium carbonate? Molecular weight of calcium carbonate is 100. So to make the calculation simplified, we will express all types of hardness in the equivalent of calcium carbonate. It may be magnesium chloride, it may be calcium chloride, but we will express the total in terms of calcium carbonate equivalent because the molecular weight of calcium carbonate is 100. So to simplify the calculation, we will express all types of hardness in the unit of calcium carbonate. Okay, now let us come to the process. So we will calculate amount of hardness creating particle in terms of calcium carbonate present in water. Okay, so for that we will use disodium EDTA. Now this is very primary concept that we have two types of solution. One is primary standard, another one is secondary standard. Primary standard means there are some type of solutions which can retain its concentration throughout the long time, whereas for secondary standard are those solution, if you prepare the secondary standard solution today, then its strength instantly changes due to the absorption of moisture. Now this complex is secondary standard. So before doing etc etc etc, first we will standardize this complex. Okay, before doing our main task, we will standardize this complex. Okay, now for this complex we need to take zinc acetate as primary standard. That means concentration of zinc acetate is known to us. We will titrate zinc acetate versus disodium EDTA and we will calculate the concentration of disodium EDTA before doing our main task. This is why zinc acetate and disodium EDTA reaction procedure is also almost same like the complexometric process you need to do for water. Once you need to calculate the amount of hardness creating particle present in water, so the process we need to follow is almost like same in the titration of zinc acetate versus disodium EDTA. So in this case, what we will do, just look at the bottle. We already prepared zinc acetate of m by 100 concentration. We have already prepared zinc acetate of m by 100 concentration. So zinc acetate will be treated as primary standard. Very simple process. We will fill the burette by disodium EDTA. Initially, we will fill the burette by disodium EDTA. And in conical, we will take 10 ml of zinc acetate. It will 10 ml. Okay. Now, particularly for this type of titration, one thing I must say, I am not going through in details. This particular titration is very much pH dependent, and we need to fix the pH of the solution as 10. Otherwise, indicator we need to use for this process will not work. Okay, we need to use one peculiar name indicator known EBT. This is Eriochrome black tea. ERIOCHROME, Eriochrome black tea. Okay, so this EBT indicator will show its color at pH 10. So before doing our main task, we need to do the solution of pH 10. For that, we will add one buffer solution. This is very uncommon term for you people. Buffer solution is a particular solution where if you add buffer solution with any solution, that will restrict the change of pH. What is the role of buffer solution? Buffer solution will restrict the change of pH. Now you have added a buffer solution of pH 7. So during the tenure of the reaction with other component during the process, it will maintain the pH value 7. No such changes of pH. So in case of EDTA versus zinc acetate, we will have to maintain the pH 10. For that we will need to use one buffer solution. That buffer solution of pH 10. And here we will use ammoniacal buffer. Ammoniacal buffer means NH4OH plus NH4Cl. A combination of these two. You particularly about buffer solution, Saurabh sir will teach you in this regarding in detail that how to prepare buffer solution, what will be the combination of the compound during preparation of buffer solution. So you just remember that we have used this buffer solution NH4OH plus NH4Cl, a combination of these two, and pH of that buffer solution is 10. So if you add some buffer solution with the 10 ml of zinc acetate in conical, pH will be 10. Clear? Now in this conical you have zinc acetate plus buffer solution. Here pH is 10. Now indicator will work at pH 10. Indicator is EBT. You just add a pinch of EBT. Pinch means 1 to 2 grains. So once you have added a pinch of EBT, your solution will turns to pink or wine red. Okay, that means indicator is work with zinc acetate for the formation of one complex compound where the color is wine red. Okay, now I'm not going through detailed chemistry, just go through the process because detailed chemistry is little bit difficult. But actually, I mean to say inside this solution, zinc acetate, as zinc acetate is there, zinc CH2 C double O, as zinc acetate is there. So I mean to say that particularly zinc acetate react with EBT. Structure of EBT is little bit difficult. That's why I'm not telling the structure of EBT. It is little bit difficult. It is a complex aromatic structure where at the cavity it contains 2 OH minus and at terminal it contains NO3 and in this terminal it contains SO3H. So this is the structure of EBT. It's very tough to remember. Now particularly just remember this part. Here it contains 2 OH minus, that is the only active sites of this total indicator. Now zinc acetate contain 2H plus, this 2H plus will react with 2OH minus for the formation of water. Now this complex is actually blocked with the cavity of the indicator for the formation of wine red complex. Okay, this is the chemistry behind it. Now if you add disodium EDTA from burette, let us place the conical just below the burette and let us add disodium EDTA from burette dropwise. Disodium EDTA will start complexing with zinc acetate. Continue, you continue addition, continue addition. Once all zinc acetate is consumed by disodium EDTA, then disodium EDTA start reacting with this complex. Where zinc acetate is blocked at the cavity of the indicator, disodium EDTA start reacting with that cavity of the complex, and indicator become free. So once indicator become free, indicator again retain its own color and it is changed to blue. You have started zinc acetate, add buffer solution to make pH 10, add EBT indicator pinch, solution color is wine red or pink. Then we have started adding disodium EDTA, addition. After a certain point of addition, your solution color will be blue. Blue means stop addition. Okay. So once your solution color is blue, stop addition. Now we will check V1H1 equals to V2H2. So V1, for this particular titration we have taken 10 ml zinc acetate. So V1 is 10 and S1 for zinc acetate is M by 100. So write M by 100. V2 means your burette reading. At least repeat this process twice, get the average reading. So this is V average and get S2 from there. Okay, so now we have, after the first process, this is preliminary process. After the first process we have standardized disodium EDTA. এটা clear হয়েছে বলো ঠিক আছে so now after the first process we have standardized disodium EDTA. Okay, now let us come to the main process. I am trying to make you understand in very simple sense. We need to calculate amount of hardness creating particle present in water. Okay, hardness creating particle, it may be calcium compound, calcium carbon, calcium bicarbonate, it may be magnesium compound, magnesium carbon, magnesium bicarbonate, it may be calcium chloride, it may be magnesium chloride, whatever it may be, but we will express finally in the terms of calcium carbonate unit. I have already told you, because molecular weight of calcium carbonate is 100. So whatever may be the result, whatever may be the composition of water, we will terms all the complex in the equivalent of calcium carbonate where the molecular weight is 100. Now what we need to do, it's very, I am trying to understand very simple sense. Let us say you have taken some amount of water. Okay, now I presume that water contains some amount of calcium 2 plus or magnesium 2 plus complexes. Maybe calcium carbonate, maybe calcium bicarbonate. So let us presume that water contains calcium 2 plus, magnesium 2 plus inside here. Now you add buffer solution to make pH 10. So I have added buffer solution to make pH 10 and add EBT indicator and add EBT indicator. So make it pH 10 by addition of ammoniacal buffer solution. Now we are adding EBT. Okay. If water contain calcium and magnesium, then we have added 1 grain of EBT. Just 1 to 2 grains, 1 to 2 crystal. Okay. That means some amount of calcium and magnesium will be trapped in the cavity of the indicator. This is a cavity, and this cavity can trap 1 calcium or 1 magnesium. মানে ইন্ডিকেটরে একটাই ক্যালসিয়াম বা একটাই ম্যাগনেসিয়াম ট্র্যাপ করতে পারে। তো আমি ধরে নিলাম এখানে টোটাল 100 ক্যালসিয়াম আছে। লেট আস অ্যাজিউম there are total 100 calcium or magnesium. So after addition of pinch of indicator, ধরলাম 5 calcium or magnesium is trapped with the indicator. Okay. So how many left? 95 left. Now at this condition, you start addition of disodium EDTA from butyrate. আমি butyrate থেকে disodium EDTA দিচ্ছি। What is the role of disodium EDTA? আমি আগেই বলেছি যে this is hexadentate ligand. That means it can bind metal ions by 6 centers. So after starting of addition of disodium EDTA, you will start absorbing calcium and magnesium. Okay. How many left? 95. You continue addition of disodium EDTA. It is absorbing calcium and magnesium. Continue addition, absorbing calcium and magnesium. When all 95 calcium and magnesium being absorbed by EDTA, then if you add extra drop of EDTA will absorb calcium and magnesium from the cavity of the indicator. Because free calcium magnesium left 95 absorbed, and left, if you add extra EDTA, it will trap calcium and magnesium from the cavity of the indicator. Okay. So now indicator again retain its color and it is go to convert it into blue. Okay. So let us again come to the process. That means butyrate filled with Na2 EDTA. Okay. And let us take a conical, add 20 ml of H2O. Let us presume that H2O contain calcium and magnesium. Add buffer solution of pH 10. Let us add 5 to 8 ml of buffer solution to make the pH 10. And add 1 pinch of EBT indicator. Solution color is going to convert it into wine red or pink. Now start addition of disodium EDTA from butyrate. Start addition. Once all free calcium and magnesium absorbed by disodium EDTA, disodium EDTA will start absorbing calcium and magnesium from the cavity of the indicator, and indicator will become free. Finally your color will be blue. Once your solution color is blue, stop addition and take the butyrate reading. Okay. So let us say this is VML Na2 EDTA after completion of the process. Let us say VML Na2 EDTA actually required to complete the process. That means VML Na2 EDTA is responsible to detect the hardness creating particle present in water. How much water? 20 ml water. I am again repeating, VML Na2 EDTA is responsible for the formation of for the detection of total hardness present in 20.
Sir,
Okay. So VML disodium EDTA is responsible for total hardness creating particle, to absorb total hardness creating particle present in water. Okay. Now before doing calculation, mind it. So we have two processes. First process was titration of Na2 EDTA versus zinc acetate. This is first titration, and for this titration we need to prepare one titration table. First, number of observations, 1, 2, volume of zinc acetate, 10 ml, 10 ml, strength of zinc acetate, in by 100, in by 100, then butyrate reading, sorry, then butyrate reading, initial, final, difference, and average. If you take two readings, then there will be average. After this table, you go for the calculation of V1, S1, V2, S2. V2, S2. V1 is 10 ml, S1 is M by 100, and V2 is your average reading coming from graph, coming from table, and calculate S2. That means strength of EDTA. And for second process, what we need to do, we also prepare one table at very left number of, এটা হচ্ছে titration tool, at very left number of observations, then volume of water taken. Here we take 20 ml for two observations, and then strength of EDTA. Strength of EDTA means you are getting strength of EDTA from table 1. You just put the value here. Okay, that is strength of EDTA. And then butyrate reading, same butyrate reading. It will be same initial, final, difference, and average. If you repeat the process, then you will have two reading, get the average. Okay. So after getting this total, let us say this finally you are getting V average. Okay. V average means volume of EDTA responsible for trapping total hardness of water. Now we will do what? As I have already told you that all types of hardness will be calculated in terms of calcium carbonate equivalent. Okay. So what we will do, as per our previous classes, you know that 1000 ml one normal of any component will react with 1000 ml one normal of another component. Same theory is applicable to 1000 ml 1 molar of any component can react with 1000 ml 1 molar of another component. Okay. So now what we'll do, here we have two components. One is calcium 2 plus, magnesium 2 plus, that are creating hardness in water. And another component is by which we are determining hardness, disodium EDTA. So now 1000 ml 1 molar Na2 EDTA equivalents to 1000 ml 1 molar calcium carbonate. As I already told you that total hardness is being um, calculated in calcium carbonate unit. Although you can calculate calcium hardness, magnesium hardness separately. ठीक है, there for that we will have to follow the separate process. Okay, but total hardness, whatever it may be, calcium hardness, magnesium hardness, will be calculated in terms of calcium carbonate equivalent. Now 1000 ml 1 molar calcium carbonate is actually the one molecular weight of calcium carbonate, as because it is expressed in molarity. So it will be 100 grams of calcium carbonate. Okay. Now, so volume required for calculating hardness আমি ধরলাম V average. So V average ml 1 molar EDTA equivalents to 100 divided by 1000 into V average. You know the concentration of EDTA getting from table 1. So V average ml and S of EDTA, Na2 EDTA, will be equivalent to 100 into V average into S of EDTA divided by 1000. Okay, that is the amount of hardness present in water in gram. In gram. Okay, let us say this is X gram. So X gram hardness creating particle present in how much amount of water? 20 ml of water. So let us redefine the calculation. 20 ml H2O content hardness equals to x gram. Okay, let us convert gram to milligram. For our calculation, let us convert gram to milligram. So for the conversion of gram to milligram, let us multiply with 1000. Okay. Now 1 ml H2O contain. I have already told you that every water parameter will be treated, will be calculated in terms of parts per million unit. That's why we have converted into milligram. So 1 ml, it will be divided by 20. Now 10 to the power 3 ml means per liter will be equals to 1000 divided by 20 into 10 to the power 3. The unit will be milligram per liter or ppm. That is the final answer. Okay. So that is the final answer of total hardness. Stop. So let us do the experimental section. First, we will fill burette by ready. First, we will fill the burette by disodium BTT. Let us fix it. এখানে দেখো ভিজিবল তো পুরো হ্যাঁ স্যার আচ্ছা না এইখানে স্পষ্ট আসছে স্পষ্ট আসছে তো হ্যাঁ সো we have filled the burette with disodium BTT. Now let us place one whitish background to detect the color. Now we will take one conical. We will wash that conical. First, we will fill zinc acetate for the standardization of disodium ETTA. So we have pipetted out 10 ml zinc acetate, and to make the pH 10, I have already told you, to make the pH 10, we need to add 5 to 8 ml buffer solution. So we have added buffer solution, and this is areochrome black tea indicator, and we will add a pinch, last a pinch of indicator, just a grain, not more than that. So it is added. Let us add another grain. Look at the color. This is this is wine red, or you can say pink. Now let us start the process. We have started from 0. Let us start addition of disodium ETTA from burette. You know the final color will be blue, because at initial state zinc acetate is reacted with EPT indicator. That means cavity of the indicator is blocked. Now once you are adding disodium ETTA started reacting with zinc acetate, and when all zinc acetate reacted with disodium ETTA, it will start reacting with capped indicator, and indicator will be free. Finally, your final solution color will be blue. That means the original color of the EPT indicator. Okay. So let us add slow local action done. Hope it is done. As we have taken very small amount of indicator, so blue color is very faint. Look here, blue color is very faint. Okay, so now let us write a reading. Reading is 10.6. okay, let us write the reading in table. My reading is initially 0, final is 10.6. so for next reading we will start from 10.6. okay, so now let us show the solution. Wash with water. Again take 10 ml of uric acetate to repeat the process. Add buffer solution 5 to 8 ml to make the pH 10. Done. And add ABT indicator. Mistakenly I have added too much indicator, that's why color is so deep pointed. Now start addition of disodium EDTA from bullet. Hope it is done. Look at the color, deep blue. Okay, so now reading is 20.1. So here reading is 20.1. That means here the difference is 10.6 and here the difference is 9.5. So as the difference between two reading is too high, so we need to check another reading. Okay. So for third reading, for observation 3, my initial was 20.1. Again we will take video output the video just call focus from your mobile. Call focus. It will take 5 to 10 minutes more to start my hypnosis. Again we will take you remember we opted for third reading because our focus ke double, because my two reading difference is too high. One is 10.6, another is 9.5. That's why we need to take third reading. Okay. Same process, just add 5 to 8 ml buffer solution. Add 1 drop of indicator. Color is visible though. Color is pink. Now start addition of disodium EDTA. So done. And my reading is 29.6. So my reading is 29.6. That means difference is 9.5. So this reading was erroneous. So let us exclude this reading and take these two reading where average will be 9.5 and calculation of V1 H1 V2 H2 will give you the actual concentration of EDTA. V1 is 10 ml, S1 is m by 100, V2 is 9.5 and S2 will be এটা কাটলো S2 will be m by 95. S2 will be m by 95. That means concentration of disodium EDTA is m by 95. Yes. We will do our main task and we will take 20 ml of water. Okay. So let us take 20 ml of water. That means we need to take water twice. ক্লাসকে একবার কল করে বলো যে আমার ক্লাসটা আমি 1:20 থেকে স্টার্ট করবো, সেটা যেন জানিয়ে দেয় স্টুডেন্টদের গ্রুপে। We have taken 20 ml water. We have added, let us add 5 to 8 ml of buffer solution.
ব্যস্ত আছে।
Let us add 1 pinch of UVT indicator. Look at the color. This is wine red. I'm asking for that color. This is wine red. This is not pink. Okay. So now start addition of my, it was my third reading of table 1, that is 29.6. Now start addition of disodium EDTA from unit. Same reaction, same mechanism. Here also at last stage there will be uncapping of metal ions from indicator to free the indicator, and indicator will retain its original color blue. So finally color conversion will be in blue. It is coming and done. Look. Okay. So my reading is in 35, exactly 35. Acha, more astonishingly, if you add some extra drop of water, that means you are adding extra hardness, your solution color will be again pink. Okay, most astonishingly, this is very simple fun of chemistry lab, that if you add extra drop, that means you are adding extra hardness, color will be pink. If you add extra disodium EDTA, then again blue, then again add water, again pink. Okay, so now let us come to the calculation. My reading is, so it will be of different table. Uh, this is titration 2, and it will be hardness of water. Number of observations, I have taken only single observation, one. Okay, volume of water taken, how much you have taken, 20 ml water. Now concentration of, so number of observation 1, volume of water taken 20 ml, and strength of EDTA is m by 95. Now let us check the Buret reading. So Buret reading will be, we have started from 29.6, okay, and our reading is 35. So reading is 35. So difference will be 5.4. Okay. So now let us come to the final calculation. This is table 2. Final calculation will be 1000 ml 1 molar disodium EDTA equivalents to 100 grams of calcium carbonate. Okay. Now what is your reading to detect hardness? It was 5.4. So 5.4 ml. What is the concentration of EDTA? M by 95. EDTA equivalents to 100 divided by 1000 into 5.4 into M by 95. This will be in gram. Let us calculate. I will give you a mobile. Let us calculate this thing. It will be 10. 120. That means 5.4 divided by 950. So it will be 0.0056 gram. That means this amount of, very trace amount, this amount of hardness is present in our tap water. Okay. So now we will do the calculation for per liter. So 20 ml H2O contain hardness equals to this one, 0.0056 gram. Let us convert into milligram. So milligram code we need to multiply with 1000. It is coming as 5.6 milligram. Done. Now 1 ml H2O contain hardness of 5.6 divided by 20 mg. Now 10 to the power 3 ml, we need to calculate milligram per liter. So 10 to the power 3 ml contain hardness of 5.6 divided by 20 into 1000. Calculate, it will be 50. So 5.6 into 50. Let us calculate 0, 5, 6, 30, 5, 2, 8. That means total hardness will be 280 ppm. So finally we need to conclude that hence the total hardness of tap water will be 280 ppm. That's it.